how I'm going to define the array? I'm going to use the square bracket. In that, I'm going to specify the size. User can able to input the array values in two ways. Suppose if I want to access any array element, then with the help of index, I'm going to access array element. Hello to all, a warm welcome to my new session on arrays. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic which I have discussed in my previous session. So I started with introduction about arrays. Along with that, I have discussed the three types of arrays, that is one-dimensional array, two-dimensional array, as well as multi-dimensional array. But in my today's session, I'm going to deal with one-dimensional arrays in detail. Along with that, I'm going to cover declaration of one-dimensional array, initialization of one-dimensional array. Along with that, I'm going to cover memory representation of one-dimensional array. Now, let's see what is one-dimensional array. So, as the name itself indicates that I'm going to have only one index or only one base value, that is A of. So, how I'm going to define the array? I'm going to use the square bracket. In that, I'm going to specify the size. So, here I'm going to specify the size. And when I have only one square bracket, then that indicates that it is one-dimensional array. So, I'm going to have only one index. Suppose if I want to access any element which is stored in this array, then with the help of index, I can able to access the element. It is an array. So, one-dimensional array is also example for an array in which each element is accessed by using only one subscript or indices or index. The only one subscript represents the position of the element in array. For example, if I write A of 10, then this 10 indicates the position of the element in the array. Array should be defined before it is used. That means, like other variables, arrays also defined at the beginning itself before it's going to used. For example, in my program, suppose if I'm printing array, then before printing, I must have to declare the array. So at the beginning itself, I want to declare the array before it's being used. An array can be defined by specifying the data type. Now, how can I define array? So, dear student, this is the syntax used to define an array. So, it is my syntax. First, I want to write the data type. So, it is data type. Array name, along with that size. Okay, so I want to write the data type. Along with that, I'm going to write the array name and I'm going to specify the size. So here, int is my data type. Array 1 is my array name, and what is the size of the array? It is 5. That indicates that this array can able to hold 5 elements, followed by The number of elements that can be stored in the array is known as size of array. So, if I store number of elements in my array, then that is the size of the array. For example, if I store 1, 2, 3, 4, 5 in my array, then what is the size of the array? It is 5. So here the number of elements that can be stored in the array is called the size of the array. So the size of the array is always integer value, and the size of the array must be constant. So the size of the array must be constant and it is always integer value. I cannot able to have 2.5 or 0.5 size. Okay, whatever the value, I am going to specify a of 5. It is integer value as well as constant value. And the size must be enclosed within the square bracket. So, the size must be enclosed within the square bracket. Now, I'm going to have the syntax. So here, first I have data type, along with that I have array name as well as I'm going to specify the size. Now, I have example here. What is my data type? It is integer, and my array name array, and it is capable to store 10 element. Now tell me, what is the memory reserved for this register number? That is 10 into the size of the data type here is 2. So 20 bytes of memory is reserved for this register number. In this example, the data type here is integer and register number is the name of the array, and what is the size of the array? It is 10. Moving further, I'm going to have the initialization. So, dear student, user can able to input the array values in two ways. That is, directly they can able to assign the value, or they can able to read the value from the keyboard by using scanf statement. But here I'm going to assign the value. Now, let me to consider simple example to initialization of one-dimensional array. Now, first I want to write the data type. Say it is integer and my array name is A and the size of the array is 3, and I'm going to assign the value 1, 2, 3, 4 and so on. And if I write the values within the quote, then it is treated as string. But what is my data type? It is integer. So how I'm going to assign? That is 1, 2, 3. Because the size of the array here is integer and I cannot able to assign character. So whatever the thing I'm going to write within the quote, that is treated as character. Now, if I consider above example, I can able to have positive numbers as well as negative numbers. See, 9, 6, 2, 8 are positive numbers, and what about -5? It's nothing but the negative number. Now, let me to write the memory allocation for this array. So, what is the size of the array? It is 5. And what is the data type? Integer. And what is the size of the data type? It is byte. So, 2 byte, 2 into 5, total 10. Total 10 bytes are reserved for this array. And how the memories are allocated, that is continue memory locations are allocated for an array. Now here I'll write the index, that is a of 0, here a of 1, here a of 2, here it is a of 3, and here it is a of 4. Now, dear student, let me to store the value. Suppose if I want to get 6, how can I get it? With the help of index. Suppose if I want to know the position of my element, then with the help of index, I can able to access the element. So, if there is less number of elements specified, so here the size of the array is 5, so I have placed 5 element. If think that the size of the array is 6, but I placed only 5 element, then the size of the array remains as it is. That is 6 into 2, 12. So 12 memory blocks are reserved for this array, but what is going to place at the end of the array? That is 0 value. So dear student, I'm going to repeat this concept once again. For example, say I have created a of 2 and I have initialized the value 1. Okay, and I left 1 position. Now, what's going to happen? Here, the size of the array is fixed, but I have stored only 1 element, and whatever the next position, there automatically it's going to place 0. So here, if there is less number of elements specified, then the size of the array, that is the remaining elements, are filled by the 0. So compiler is going to fill the rest of the fields by the value 0. Now, how can I access one-dimensional array? Now, see here. This is my array declaration. Suppose if I want to access the array, then how can I? See here, it is 5. That means 5 elements I want to read. And how I'm going to read? One after another. So it's nothing but looping or iteration. And here I can able to use for loop, while or do while. But most of the time we are going to use for loop, because we know how many times I want to repeat this statement. I know the iteration. For that reason, I'm going to use for loop. So, for, it is my initialization, this is my condition, and this is my increment. And I'm going to read the input with the help of scanf, %d, and ampersand a of I. So here I is always going to represent index. Now suppose if I want to print the value, how? I'm going to use the for loop once again, because I want to read all the elements one after another. So I equal to 0, semicolon, I less than n, semicolon, I plus plus. So dear student, please note down this condition, because I'm going to use I less than, because I is going to start from 0. So 0 to n minus 1, for that reason it is I less than n. Now I'm going to use printf array element equal to %d a of I. So this is the way I can able to display the array element. Now I'm going to have simple program. So this is the simple simple program used to read the array element and used to print the array element. Now, dear student, think that my array size is 3 and I'm going to read the value 1, 2 and 3. So, the actual execution of the program is going to start from main program. Here I have array size. So, instead of taking a of 50, what I will do, I'll make it 3. So, a of 3 and I is nothing but index. So, I is always going to represent index and n is nothing but my size. So, n is nothing but my size. Now, I'm going to give the message to the user that specify the size of the array. So, I'm going to read array. After that, I'm going to specify the message to the user that enter the element one by one. See here, to read the element, I'm going to use for loop because here I want to read 1, 2 and 3. So, initially I is 0, I less than 3, n is 3, I less than 3, it is true. So, I'm going to read first value, okay, and where I'm going to store in my array of 0, I'm going to store 1. Now, I'm going to increment I by 1. Now, I is 1. 1 less than 3, it is true. I'm going to read my second element, that is 2, and where I'm going to store in my array of 1. Now, I is incremented by 1. I is 2. 2 less than 3. 2 less than 3, it is true. So, I'm going to read 3 and where I'm going to store in my array of 2. Now I is going to increment by 1. Now I is 3. So here 3 less than 3 condition is failed. So the control transfer to next block or next statement. Now I want to print the element 1 by 1. Now I want to print the element 1 by 1. Now dear student, I'm going to have the for loop. So, I'm going to have the for loop for I equal to 0, semicolon, I less than n, semicolon, I plus plus. Printf percentage d a of I. And if you want any message, here you can write printf the array elements are, okay, then I'm going to have the for loop. So here I is 0, 0 less than 3, it is true. So I'm going to fetch the value which is present at the location a of 0. So I'm going to get the output 1. Now I is incremented by 1. Now I is 1. 1 less than 3, it is true. So I'm going to fetch the value which is present at the location a of 1. So I'm going to get 2. Now I is incremented by 1. I is 2. 2 less than 3. 2 less than 3, it is true. So I'm going to fetch the value which is present at the position a of 2, that is 3. Now what I'm going to do? I'm going to increment I by 1. Now I is 3. 3 less than 3, the condition get failed. So the control comes out from this for loop. So this is the way I can able to read one dimensional array element as well as I can able to display one dimensional array element. So dear student, this is the way I can able to read one dimensional array as well as I can able to write one dimensional array. Moving further, I'm going to have memory representation of one dimensional array. That means how the memories are represented. When I write character A of 5, then the size of the array here is 5, and what is the data type? Character, and it is capable to hold only 1 byte at a time. So 1 into 5, total 5 memory locations are reserved for this array A. So this is the memory representation. Now see here, A of 0, A of 1, A of 2, A of 3 and A of 4 are nothing but my index, as well as this 1000, 1001, 1002, 1003, 1004, these are nothing but the address, because the size of the character is 1 byte. So 1 byte of memories are reserved for individual element. So here what is the size of each block? That is 1 byte, because the data type here is character and it is capable to hold only 1 byte at a time. Instead of that, if I have int, then what is the block size? It is 2 byte, that is 1000, after 1000, 1002, 1004, 1006 and 1008. So this is the address of my array in the case of integer data type. But here it is character, so 1 byte. Now let me to consider the int. So here data type, here integer, and what is the size of the array? It is 3. Now think that I'm going to read 4, 6 and 8. Okay, now let me to write the memory representation first. Okay, so it is 3 into 2, total 6 byte of memory is reserved for this array A. And what is the capacity of each block? That is 2 byte, 2 byte and 2 byte. For example, array index starts from A of 0, A of 1, A of 2. Think that array address starts from 1000, then next time 1002 and next time 1004, and I'm going to store the element in my array. Suppose if I want to access any array element, then with the help of index, I'm going to access array element. And this is my starting array element and this is my ending array element. And it is represented with the help of array index A of 0 and here A of n minus 1. Now see here. Same example, two blocks of memories are reserved for individual element because the size of the data type here is 2 byte. For that reason, two blocks are reserved for single array element. So, array element A of 0. So, what is the array index here? A of 0. For A of 0, 2 byte of memory is reserved. For A of 1, once again 2 byte of memory is reserved. And A of 2, once again 2 byte of memory is reserved. If I take float, then what is the memory representation? Float can capable to hold 4 byte of data at a time. So, 4 byte of memory blocks are stored or reserved for individual array element. So, this is the way I can able to represent one-dimensional array. So dear student, in my today's session, I started with one-dimensional array. Along with that, I have covered how to initialize one-dimensional array, how to access one-dimensional array, and how to display one-dimensional array. Along with that, I have discussed memory representation for one-dimensional array. Dear student, in my next session, I'm going to deal with two-dimensional array. Along with that, I'm going to deal with declaration of two-dimensional array, initialization of two-dimensional array, and how to access two-dimensional array. Along with that, I'm going to deal with multi-dimensional array. So dear students, let's meet in the next session with more information about arrays. Until that, keep watching and keep learning. Thank you.